Done? Okay, so this is a new topic we added this time under the head of our reliability analysis, system reliability, and we will conclude today's session as well. So if you see the last form and major topic what we consider for our discussion is optimizing on the uncertainties. Primarily here we are going to count two important aspects. What? One is engineering economics involved behind it. Number two, for to execute that, what are the computational challenges you will be required to handle. Understand? So what is our current motive is to select and optimize the system well within under the uncertainties. Right? Now, as we have been already discussed thoroughly from past 15-20 lectures, what do you mean by uncertainties? That to use any particular system or component, there is a SOP, standard operating procedure. Even I will follow a standard operating procedure. Does it mean that no failure will occur while that instrument, that system, that device is under the operation or in active phase of its users? Is it? No, nobody can guarantee. If the device or component or system has been designed or is designed with a rigorous R&D, okay, with a lot of fail-safe options, component by component, without keeping cost as a primary factor, but not at the cost of quality. Okay? So, in that scenario, what will happen? It's quite possible that the instrument or system cost may rise exponentially. That means double or n times of the expected median or normal cost. Done? And therefore its uses will be limited. Limited means maybe I may be interested to use it for scientific purpose. Then I will not bother about the cost because primary is the research and it's a finding, without compromising the quality. Okay. Number two, probably my end user is a defense system, right? I am a defense company, I run a defense company, and my end products are supposed to be used by the armed forces. Then probably the cost will be not a primary matter. Is the cost concerned? Yes. Yes. If they will go for a long-term war play with the enemies, then the number of armaments they will be used, then the cost will matter. Right? But for a short run, no. Is it an initial criteria? No. Because first I want to safeguard my country, my system. Cost comes matter, but it's the secondary. Right? But let's say tomorrow I am a consumer, a normal consumer, and supposed to be using this kind of digital marking pen. Then probably cost will be one of the very important criteria. Why? Because it decides that whether I can afford it for my daily purpose or daily uses or not. Right? And for that purpose you go for the bulk manufacturing. It has a different approach. Semiconductor industries follow different bulk manufacturing approach. Like heavy engineering plants like steel industries, they also go for bulk manufacturing. In one case you are able to reduce the cost using bulk manufacturing, but in other case like steel manufacturing or aluminum manufacturing, standard cost is remain same because they count it as per the tonnage. So if you are going to take it, let's say 1000 ton, they may be reduced little bit of price, but you won't get 20%, 30% discount. Get my point? So there are two different kind of commercial uses, whether it is industrial or non-industrial. So therefore, when you are going to select a system, the very first matter you have to argue is cost. Done. Now this cost is finalized based on certain parameters. Can you help me to identify? One is mathematical model based, correct? Being an engineers, we can very well identify that the system or a component backed by a complex mathematical model resultantly leads to a very costlier system, correct? What mathematical model states? It states the physical behavior, narrate the physical behavior of a system or a component, correct? Class sorry for interrupting. So, normally mathematical model shows the degree of complexity, degree of uncertainty involving with the system or a component. Thereby, it has a direct connection with the per unit cost of an instrument or a system. Now, to verify it further, next step what we do after mathematical model, we go for to understand the physical model of the system. Physical modeling. To verify the physical modeling, what we do? To verify physical modeling, we go for a certain kind of test. Correct? In other words, as a layman language, we call it experimentation. If that's okay, then we go for a full scale prototype. We prototype a system, right? Prototype you can go for 1:n scale also. Normally n is to 1, because if a size is, let's say, 4 meter by 4 meter, so rather than designing a 4 meter by 4 meter, I can design a 4 centimeter by 4 centimeter, or maybe 0.5 meter into 0.5 meter. Smaller dimension will be resultant to give me a more flexibility to handle and also lead to a smaller investment cost. So sometimes we go for n is to 1 scale. Once that is successful, then we go for even full scale. Even prototype can be divided at 2 stages, right? And then is final certification, verification. If it is successful, then assembling, final testing in a ground environment. Ground environment means now your user will take a trial as per their wish, the kind of challenges they face. If you are including these things, remember, then the product cost will be also escalating. Can you help me to identify in what kind of users they do these kind of tests? Normally you see the armed forces, defense users, because they are the very critical users. In what circumstances they will use? What will be their SOP? What will be their system architecture? Do they ever disclose it to public? No. Right? It's a highly confidential. Isn't it? So that's why in those scenarios, they ask you industry persons to come with your product. They select the environment, they select the range, and then they go for a rigorous testing. If you passed it, they will select your product. But as far as this small commercial application is concerned, I don't need to go for that line. Probably this much level of validation is more than sufficient. If it is a cheaper product, normally you know that I have already told you that an industry, if they are going to make n products, they will test some 2, 3, 5% product randomly. If those 5% or 3% product passes their parameter, they pass all the n products, 100% product as a batch to go for commercialization. And little bit of sophisticated product, then they go for a per unit product test. Okay? You can compare this simple digital pen with your iPhones. Okay? So we are not supporting any branding here, but this is an example. Or even you take the Samsung or any other company. So other than Apple, normally other companies, they try to introduce 2 different range of mobile. One is the highly customized version for their premium product, they call it. Another is called non-premium product. Non-premium product, what they do, if they are going to manufacture 1,000 pieces of phone, they will hardly test some random phones, 20, 30, I don't know what is their number. Obviously it's company's policy matter, but they do something somewhere around 2 to 5% product test maximum. Okay? On the other hand, if it is a premium product, probably they will invest more manpower, more time, more automation, and try to test each and every product. Correct? So that's why these things does matters. Clear? Now once this is fixed, what you will do? Idea is clear? So we are going to fix certain points over discussion while we are discussing over here. One is that taking some financial insights while we are doing engineering model of these things. If you do so, what exactly happening? We are not going to dig deep into the different kind of assessments involved in the economics. Okay, remember we are an engineering fraternity. We are handling the technical know-how of that particular product and try to work out whether the mathematical model, physical model behind the instrument or the system, can we do something where without compromising the SOP and without compromising the system parameter, we will be able to give some idea to reduce the budget or per unit cost of the product. But remember that punchline will be remain same. Simplest mathematical model will be most of the time will be leading you to produce a product using a simple approach. Simple approach means obviously it will be leading to cost effectiveness. On the other hand, complex mathematical model will be resultantly leading to the degree of complexity involving in the physical manufacturing of that particular product. That's the reason that indicating the higher cost of a per unit product or per unit system. Okay? So we are trying to materialize that particular thing. Now, if you will take the cost into a factor, question is it involved with the risk assessment or not? By compromising or by considering the cost as one of the primary factor of a system design or a product design, okay, to assess its reliability, to assess its failure, to assess the amount of degree or of risk involved into it, okay? And when we particularly say uncertainties, what do you mean by uncertainties? That means we are following a SOP. We have answered few minutes back. We are following a SOP. Still, we don't guarantee that the product will remain available 100% time during its active life period while I am using it. Something could happen. Maybe it could be my manual failure, or some kind of catastrophic failure experienced by the individual component of this particular instrument. But ultimately this system will be not able to perform or be available in its usable form, right? Probably it requires some maintenance. So after maintenance it will remain available for me. Or my maintenance engineer says that, okay, sir, now this product is not in that condition to be maintained. Even we will try to do it, the amount of cost on investment of this particular product will be nearly 60 to 70% of the original cost, right? Now you all agree that when we first time we started using a component, it also depreciates in terms of its life and thereby depreciate in terms of the product cost. If the original cost was 100 rupees, after 5 years, this product which is in my hand right now won't be cost 100 rupees. Why? Because I have used it for 5 years. By this period term, its performance is already being depreciated, right? So those costs will be also added. If I will ask an economist or a chartered accountant or some financial expert or a banker, they will say that, sir, I will count the depreciation of this product per year based on this much rupee, right? Then you have already used it. So I am going to now charge you 40 rupees. So the original product cost after 4 years is, or 5 years is 40 rupees. Okay? Done? Now, the original cost was 100 rupees. Getting my point? Now let's say today this component is going to cost you another 40 or 60 rupees in terms of maintenance. Is it a wise decision to go for it? No. But if it is now costing you 4 rupees, should I go for that? Answer is yes. Right? Even the depreciation cost is 40 rupees only, but it is costing me only 4 rupees. So if I investing 4 rupees, probably my maintenance engineers convey that, sir, you are supposed to use it for another 2 or 3 years. It's a very good investment that is, right? So I will go for my risk assessment, taking the cost into consideration. And in fact, if it is an industrial applications or any commercial application under the consideration, you should always go for it. Correct? Now, if you will combine all these assessments into the picture, this simple equation, what it states that you are going to suppose to use overall cost factor under the consideration, which is primarily the inherent cost, that is number one. Number two, if the degree of uncertainties or any kind of depreciation is involved, this is also does matter. Remember that, like in terms of position, distance, timing, location, there are certain parameters. So remember all this will be integer value. Combining these two factors, 1 and 2, I will get one coordinated or combined value. Okay? Which asks me that the expectation involved to that cost. Expectation, you remember, probably your digital communication expert would have been taught you during the sampling and signal systems. One is normalization, one is the expectation. Expectation is in the simplest language, you can say is also kind of mean value. But it's a mean value involving to certain factors. Like for example, here I am calculating the expectation of a cost. Now cost is itself a variable which depends on certain parameters, right? So the average of that value, what we take is the initial cost plus the depreciation cost. Okay? That means with time how much time lagging. So if you will do that, you will get the overall optimized value in that depreciation, which is nothing but the argument of the minimum value of that expected cost. Getting my point? So Ci is, let's say I is some integer value, so it will give me some finite numbers. Expectation of that, I will get the average of it. Clear? Based on this expectations, what I will do, I will take the minimum amount into the consideration. While I do the risk analysis, or probably I am taking that risk, you work out the argument of that minimum value. This will give you a figure that the amount of risk involving in this particular instrument or system is now worth to consider at this moment or not. Or I should replace it with a completely new assembly line if it is factory. I should replace it with a completely new pen if I am an end user. Okay? So obviously that factor does matters to us always. Okay? And we are arguing for that particular parameter. Getting my point? Briefly, just I am referring to this particular, like one system demonstration is given while we are involved. Now, can you tell me, answer one thing, that where is then this computational modeling is involved? Because if we see, like if there is a very complex mathematical model involved behind a system, correct? And during the design stage, during the development stage, I want to understand its physical or chemical behavior, considering all the risk and cost into the matter. So today's age, I can use a sophisticated simulation platform, which can normally give me around 90 or 95% glimpse of a actual physical life behavior. How this, if this pen is in the R&D stage, how it will perform, 90% of its activity I can simulate. I am not asking about real-time simulation, I am talking about typical sophisticated simulation platform. Remember, simulation is also backed by a mathematical model, correct? When I say take a mathematical model is typically an idealistic environment. It's a theoretical environment. That means maybe there are so many other factors which is involved in a real life scenario. For example, temperature, environment, humidity. Right now I didn't consider those things. Why? Just to analyze, create a simple condition, test it. If it will pass that test, then go for a complex condition. But the mathematical model involved behind that instrument is if itself a complex, then what will happen? Then the simulator, which is designed to simulate that environment virtually, must have an ability to handle that degree of complexity. Now that simulation tool is itself designed by your algorithm, because somebody has developed that tool, right? So that must also have a capacity to handle that degree of complexity. Correct? Now in that you are supposed to handle that degree of complexity using a simulation platform in a virtual environment. What do you think? That simulator will itself be cost effective or costly? Costly. Number two, you consider a kind of simulator which probably able to mimic 99% of the real-time environment. Then it will be even further costly. If you heard, sometimes people called it emulator. Rather than simulator, they called it emulator. For example, whenever these commercial pilots, doesn't matter whether it's a helicopter, you talk about avionics sector, doesn't matter whether it is a defense or commercial purpose, they first trained their pilot in their school, in their teaching school, based on emulator. Emulators almost give the exactly similar real life scenario of a 3D, because when you fly something, the world is 3D, not a 2D, isn't it? I am riding something on road, I can treat it as a 2D, correct? But as a driver, but as a pilot, it's a 3D, correct? So that complexity is very different. Level of complexity is altogether different. So the simulator which is designed based on some algorithm to mimic this complex mathematical model will itself be costly, right? I cannot figure at that point of time. So you have to combine all these things, right? So one of the two important thing is technical system model. What is the technology involved behind it? Another is the economics involved behind it. Both things does matter. Which will come first? Technical model. Okay. I talk about a lot of economics today, but I failed to perform it, even during the lab testing. Does it matter? Does it matter? What your bosses will, tomorrow you are going to join a commercial life, an industry, or probably you are going to do a startup. You will have some end users. So when you will go for a very first testing, what you will test? Whether my know-how is working or not, you will test that thing. और फर्स्ट टाइम यू विल बॉदर दैट व्हाट इज द कॉस्ट. अरे भैया हमारे एंड यूजर ने बोला है 10 रुपए के अंदर देना है ना, कॉस्ट शुड पर यूनिट कॉस्ट शुड बी लेस देन 10 रुपीज. फर्स्ट यू विल टेस्ट दैट इट शुड परफॉर्म, देन यू विल टेस्ट दैट इट शुड परफॉर्म बेस्ड ऑन वेरियस पैरामीटर, देन यू विल टेस्ट दैट इट शुड ऑप्टिममली परफॉर्म, देन यू विल चेक दैट व्हाट इज द पर यूनिट R&D कॉस्ट. Then you will test that if I will go for a commercial manufacturing. Whenever you go for commercial, obviously it's a bulk, always. Maybe for your sector bulk is 100 in numbers, maybe somebody's sector bulk is 10⁶ in numbers. That can vary, that n can vary. But when you look for bulk manufacturing, then you will count all the cost. What is that? Operation cost, manufacturing cost, right? Number 2, maintenance cost. If you are providing some kind of AMC to your end user, that cost. Then your end user will understand, sir, okay, if I am buying this product from that company, XYZ company, then my per hour cost or per day cost of its entire lifetime will be this much. So first we will go for technical system modeling, then we will go for economics modeling and the surrounding parameters again. But ultimate goal is this, okay, to build that particular target. And if you see, you again reach back to the same expectation. Okay? Initial cost, development cost, then under the uncertainty, the degree of cost. Okay? So these are the two primary goals. If you are expand, this is the expression for your goal. Okay? This is one of the very simplest, but remember, very important model to judge the any kind of techno-commercial activities and its economic implications. Okay? Which is under the syllabus. Some of examples are given. Feel free to go through it for your better understanding. Remember, these are the non-engineering applications. It is only for your assessment purpose, understanding purpose. Parallelly, I would recommend you to refer to go for some techno-economical model. So for your better understanding, if you have a time. Limitation of expected cost and the risk involving into it. What do I understand with this? Let's say, we'll say that as I say that I'll bother that this product cost should be less than 10 rupees. Okay? Now this target I maybe have from the beginning, or I may not have if I am a product designer, product developer or a manufacturer. Correct? But is this statement valid for all possible kind of applications? Answer is no. If it is a purely commercial application, and you know that you are not one among the unique in the world, that means you don't have a sole proprietary authority, or you don't have a monopoly in that particular region. Getting my point? I'll give you a couple of examples. Take the example of one of the commercial company in the consumer dietary. Okay? For example, you take example of, let's say, some kind of soaps or some kind of brushes, some kind of daily uses items we are using in Indian territory. Okay? Now in US also human are there, right? Is it necessary that the kind of soaps, paste and these things are popular in India? The same thing made by the same company will be equally popular in Europe or in US. But soaps are popular. Brushes, toothpaste are popular. I am wearing this belt is also popular. It is made by somebody. Correct? But what does matters? Two things. What is the per capita average income of that particular nation? Number one, it indicates that what is the maximum average nominal expansion capacity of that particular citizens in the country or in that region. You can take even a state level also. We can compare our state Odisha with some probably highly expensive state or the developed, for example, take New Delhi, right? Probably in New Delhi, per capita income will be much more on an average as compared to Odisha. Expenses also more, correct? So that means if I will fix income which may work in this Sambalpur region very beautifully, may not satisfy you in New Delhi. Possible. But maybe more than sufficient in Andaman and Nicobar. I am living in islands territory, don't have a much thing to do, don't have a much option to spend also. So by force or by nature, I am relatively living a very simple life. Correct? Then probably the same salary will be, or same income will be much more than that. That is the reason what happened, that what kind of product you will be supposed to use does matters, and it is expected value. If I am talking about this simple digital pen which I am using for marking purpose on a digital screen, then if my vendor or my manufacturer is keeping a target that in any way I have to on an average satisfy my 95% of users or 99% of users, keeping the price of per unit cost less than 100 rupees. Probably possible. Not at the very first or second round, but after rigorous R&D again and again, with time you will be able to find a way to reduce the product per unit cost without keeping it at risk. Risk means without dissatisfying my end user. I am an end user for that company, your company, right? But on the other hand, if it is a defense application, then you will never keep this target as a manufacturer or as a product developer, nor your end user. Who is your end user? Armed forces or some reserve forces, for example like CRPF in our nation, right? Or BSF. They will never give you this target as a first, that you manufacture this digital pen or narration within the 100 rupee or $100, right? First go for it. We will go for without compromising know-how and know why. We will test it. Then we will finally fix a price, because price does matters without involving a risk, keeping the uncertainties in mind, keeping the risk assessment in mind, and then we will think of about to reduce the cost again with time. Clear? But that will not be our first target. And these two things will be critically decide that how your CI and CD, that means the first factor and the second factor, these two factors, okay, will does matters. Okay, remember this is the same expression version of the model. Okay? Or you can say it is a uniform or generalized expression of the model. Ultimately, there are two important things. Okay? You have to take care of these two things. Rest will be automatically assessed in these diagrams, as you can see that the different parameter evaluation are given. If you are interested, go to it. Otherwise, you can go. Okay. And the second, the common time, very usual time, what I can say, that the cost uncertainties involved in this year is not including the detailed assessment done by the economist. We are not involving that. What is that? Economists involve the complete supply chain process. Understand? A R&D guy or a technical know-how person who involved in the design and development phase do not include those parameters. Okay? The last question is that can it affect your overall product cost? What the economists or the financial experts of the company do? It can. It doesn't matter at what cost, for what kind of application, whether it is a health application, defense application, commercial application, industrial applications, you develop these products, okay, by a very smart supply chain system. You may be able to outplay your competitor who have probably even a better product performance as against the individual parameters of your product. Possible, especially in the commercial applications, also in the defense applications. Okay? Lot of narrations, okay? Lot of information, psychological wargame, advertisement, branding will also affect the per unit system cost or the product cost. Remember, under the head of system reliability or the component reliabilities, product performance and risk assessment, we are not taken care of that as our part of assessment. Our primary goal is to consider the know why and know how, right? Considering the all possible risks involved into it, how this particular product or system will work well, optimally, without compromising the quality throughout its life cycle. Okay? So we have concluded this particular topic at this particular level within a code that we are not going to count all other external financial implications involving behind. Done? With this, I am closing this session. Okay? I think almost it's our last lecture. Done? So I wish you all the best to all of you for your entire future endeavors to come. Done? One non-technical thing. Okay. We remember wherever you will be in your life or whatever you will do. Okay. Just wake up one more time, subject to if you are falling in your life. Okay. Long run, remember these technical things are very small. What psychology will ask you, will play with you in your life is much bigger beyond that. Okay? Much bigger than network theory, much bigger than industrial automation, much bigger than system reliability, much bigger than AI, something. Okay? The role of these things will be a penny in your life. What you can do that, never compromise with your attitude, fix your goals, see your dream with open eyes. Okay? Aware, Shivanand, Adityanshu, and all other class. Okay? See your dream with open eyes, not with the closed eyes. Close eyes. Next day morning you will wake up, you will forget. Okay? Nobody is perfect. So days will come, you will be falling short of to achieve your goal. Right? There will be some bad days, so-called we call, right? I also say, but trust me that when you will ask to some of the sons, they call that nothing is good or bad. They might be correct, okay? Because it's like they are in the top of the mountain, so their foresight is much bigger, much wider than us, right? But doesn't matter, whatever the day you will perform, you are going to join your like the next chapter of your life, or I would say that the professional chapter of life. Okay? So it's immaterial that what class has given you what, probably out of this entire engineering knowledge, in your life you are going to use it less than 1%. Okay, whatever under the head of degree program you learn. What important is that in these 4 years, how do you evolve yourself, right? And you keep on evolving yourself. Okay? With one particular note and a humble request that whenever you fall, wake up one more time. Done?
Thank you, sir.